Hello, here's a little nudge if you need it on MOP WM4. This may remind you of a mop that you've seen before with a couple of boats, and they're described as being anchored in the water somewhere with waves going by. And they give a hint that they have given before, and that is to draw a diagram to start this one. So a simple series of crests and troughs like this would be helpful. And then just mark a location for boat A. You could just do it like that, at the top of a crest. And then it says boat B is at a low point. So again, you have to pay attention to the details, because in this problem it says there are never any wave crests between them. That means B has to be in the next wave trough over at its low point. So that's where that is. In the previous mop, they asked you questions about wavelength and amplitude. This one is also going to start with a description of the wavelength. So hopefully you remember how you went about doing that one. A wave is not the distance from a crest over to the next trough. It's from a crest, like this one here where A is, over to the next crest adjacent to it. So that's twice as far apart as the boats are. So if you use this distance as the boats are, that'll be related to your wavelength. The next thing they ask is for the frequency. So there's a couple of key words here. I'm going to remind you of what frequency describes. There's different ways to describe it, but for something that's happening on a regular basis, the number of times it happens per unit of time is what we call the frequency. Things that are spinning, things that are bobbing up and down, things that are blinking, for example, all have frequencies. In this case, we call it waves per second, or maybe cycles per second. So if you look at what we have here, 3 complete cycles in 12.7 seconds. So the number of waves in 1 second is much smaller than 3. So what we would look for is the number of cycles, I'm going to abbreviate there, over the amount of time that those number of cycles takes. Cycles per time. So we divide those numbers and we'll get the frequency. So we've got the wavelength, we've got the frequency, and finally the speed. The speed is related to the previous two values that you just found. This is a relationship known as the wave equation. It's a very important one to use anytime you're dealing with waves. This could include water waves, sound waves, light waves, anything at all. And the relationship says that the speed of any wave can be found by multiplying the frequency times the wavelength. That symbol right there that I just drew is the Greek letter lambda, and it's the symbol we use for a wavelength. So once you found the first two values, if you found them correctly, multiply them together. Don't round too much, always leave a few extra digits. Type it in here into the speed box, and that's your third and final value. So of course yours might look a little different than this, but look for the same kind of information. Notice here too that they're going to give you some extraneous information. Do you see that the vertical distance between the boats is described as 8 meters? And that's meant to make you think, do you need the vertical distance to get a wavelength, frequency, or speed? The answer is no. That's only used for the amplitude, not relevant here. So watch out for those foolers. Hopefully this gets you rolling, and if you need any more help, come and find me in the classroom.